Welcome pre-calc students. This video is going to help you to prepare for the quiz on trigonometric functions that we have on Monday. I know Mondays are always a little tricky having a quiz, so this can help you study over the weekend. So here we're asking for positive coterminal angles and negative coterminal angles. So again, just a quick reminder, if you're not sure what a coterminal angle is, it is an angle that has the same terminal side. So if I had a 30-degree angle, a coterminal angle would be 360 more than that. So 390, 30 degrees, and 390 degrees would be coterminal angles because they end in the same spot. We are starting from here, 0 degrees. Alright, so if I took 172 and wanted to find a positive coterminal angle, I would just add 360. And I would get, let's see, we have to do this without a calculator. So 2, that would be 13, carry the 1, 3, 4, 5. 532 degrees. And if I found a negative coterminal angle, I'm going to want to subtract 360 degrees. So here, I'm going to find the difference between these two. So let's see, I need 8 more to get to 180. 180 is nice because then 180 more gets me 360, if that makes sense. Okay, so it looks like 188, but it's a negative 188. So I want to think about if I take away 360, I'm going to have a negative 188 degrees. Alright, and then the reference angle. So I want to think about where 172 is, and I really strongly encourage you to draw the angle. Think about 172. Alright, here's 90, here's 180. Alright, so 180 is too big, so 172 is here somewhere, and how much more do I need to get to 180? Well, I need 8 more. So my reference angle would be 8 degrees. Reference angles are always positive, and they're always between 0 and 90. If I was on a quadrantal angle, meaning if I ended on an axis, then we wouldn't have a reference angle because there is no angle less than 90 degrees. We don't really need a reference angle because here we can figure out that point very simply. Alright, so I'm just going to do one example from each. But the main concept here is you need to add 360, subtract 360, and I'm pretty sure we'll post the answer keys for this on Edline so you can check the answer keys. And you'll also be working on this in classes. I just realized something that's missing on this next graph. So determine the exact value for each of the following trig functions. Sine of theta. Okay, so then I go over here and I look for theta and I'm like, whoa, it's missing. Okay, so we really need to draw theta in. So if you can all please draw theta in the lower right hand corner. Alright, so now that we know what theta is, sorry, that should have been given to you. Now we can find what sine theta is. So we need to know the trig ratios. So sine is opposite, so it's going to be the side opposite my angle, opposite over hypotenuse, 6 over 12, but I want to simplify. 6 over 12 is equal to 1/2. Alright, cosine, so adjacent over hypotenuse, looks like x over 12. I can't simplify that, just going to leave it. And tangent is the same as sine over cosine. We've been practicing those, so you could take these two and divide them. But it may be simpler here, just go tangent is opposite over adjacent. So 6 over x. Alright? Okay, now cosecant, if we're very confident in these answers, then cosecant is just the reciprocal of sine. So 2 over 1, or just 2. Secant would be the reciprocal of cosine, 12 over x. And cotangent would be the reciprocal of tangent, so x over 6. Alright, so that would be completing the 6 trig functions. Here we're asked to find the exact value for each of the following trig functions. Again, theta is not listed, so I apologize. That should have been there. Okay, so I'll leave that one for you to do. I don't need to do both of them for you. Alright, here we are converting. So if we want to convert from degree to radian or radian to degree to radian, if we want to get rid of the degree, we need to multiply by a form of 1 where degree is in the numerator, so degrees will cancel out. And we know this ratio of pi over 180 is a special form of 1. If we think of a circle has 360 degrees, halfway is 180. And if a circle has 2 pi, halfway is pi. So this far around the circle, the same distance around the circle, 180 and pi are equal. So we can set that up as a form of 1. So here the degrees cancel. We want to do this in our heads. Here I can divide by a factor of 10. I have 20 pi over 18. And then I want to try to find the biggest factor they have in common. 2 works, but can I get anything bigger? 3, 4, 5, 6, 7. It looks like 2 works. Okay, so I divide out 2. I get 10 pi over 9. So that would be my final answer. You will not get full credit for something that's not simplified. So make sure you're simplifying all the way. All right, so that's going from degrees to radian. So that would be 10 pi over 9. And then if I wanted to go backwards, that kind of doesn't look like there's a division, but there is a division. To go backwards, let me erase this so we have some space. If I start with pi, 3 pi over 5, and I want to get rid of the radians, I want to put my radians on the bottom, my degrees on the top. So my pi's cancel, and then I need to simplify. I have 3 times 180 divided by 5. So here I know that there's a factor of 10 in here, right? So 118 times 10, but then 10 has a factor of 5, so I'm going to break 10 into 5 times 2. So I have 3 times 18 times 5 times 2. I can cancel out my 5 factor, and what's left on top is 3 times 18 times 2. So 3 times 2 is 6. 18 times 6 is 48. And 6 times 1 is 6, plus 4 is 10. All right, so I would say that 3 pi over 5 would be 108 degrees. Okay, so I would put 108 degrees. All right, so I'll leave the others for you. The negative, it just, means we're going, instead of going up, we're going down 7 pi over 12. So our degree would also be negative for that. Okay, given a central angle of 72 degrees, central angle is here, determine the length of the intercepted arc in a circle with a radius of 12. Express your answer in terms of pi. So there's a formula. I think we're going to give it to you. It's a pretty simple formula, but it's given on the final exam. So S equals r theta means the arc length equals the radius times the angle measure, but this needs to be in radians. So we need to change that 72 degrees, change it to radians first. All right. So 72 is 9 times 8 times pi. Those are all in the numerator. And in the denominator, right, that's over 1. And then in the denominator, I can see, okay, there's a factor of 9 and 18. So here I have 9 times 2, or 9 times 20. So 9 times 20. I can simplify the 9s. Then I see, there's another factor here, 4. So 8 is 4 times 2. And 20 is 4 times 5. Now, some of you might not get why I'm factoring it out like this. I'm actually showing every single step, kind of preparing us for it when we get to a unit on rational functions, where we are talking about all the factors. I want you to see that we break it up into all the factors and then simplify. All right, so it looks like 2 pi over 5 is our radian degree measure. Now I can plug that in for my theta, and I can solve the problem. So my arc length is going to be the radius 12 times my angle measure, which is 2 pi over 5. And then I want to simplify if I can, or at least combine that. So 24 pi over 5, and it doesn't look like it simplifies anymore. So my arc length is that, and I want to use units if they gave me units. It says 12 inches. So this length is in inches. This length also we're going to talk about in inches. So 24 pi over 5 inches. And I'd rather have the exact answer than the approximate. So if you were allowed to use a calculator, you could type that in. Remember, pi is just a number, 3.14159. But we would like the exact answer. All right, great. So here's another intercepted arc problem. This one, you have to find theta, right? So if you're given S and you're given R, you need to find, you're given these two, plug those two in, and figure out what theta is. All right. Now, let's see, determine the exact values for each of the following trig functions. If we are given one trig function, we know what's what, right? Sine is opposite over hypotenuse. So I know actually a lot about my triangle. So here we have kind of a demonstration of what's going on. Theta is this central angle, right, closest to the origin. Okay, so my opposite side is 2, and my hypotenuse is 3. So I now need to figure out what is this side. So, oh, that looks like a 0. It's not 0. We need to figure out what is this side. So we can use Pythagorean theorem and go a squared plus b squared equals c squared. And c is always our longest side, so 3 squared. And this doesn't matter, a or b, so 2 squared. Alright, or you could do x squared plus y squared equals r squared. It doesn't really matter. Okay, so we have a squared plus 4 equals 9, subtract 4, and we get 5 equals a squared, square root both sides, and a equals the square root of 5. Technically plus or minus, but we're not worried about the negative version right this moment. So the square root of 5 is our a value. Now we can find all the trig functions. So we know this one was 2/3. Cosine would be adjacent over hypotenuse, root 5 over 3. Tangent would be opposite over adjacent, 2 over root 5. We could also say sine over cosine. The 3's cancel and we get 2 over root 5. But this is not our final answer. We need to rationalize our denominator. So we multiply by the root 5 over root 5. Here we get 5, because 25, square root of 25 is 5, and on top we have 2 root 5. So our final answer, 2 root 5 over 5. Okay. If I was to go into cotangent, I would take my initial one, my initial ratio, and I would reciprocate that, because then I get root 5 over 2. If I reciprocated this, then I'd have to rationalize again. I would end up with the same answer, but it's much easier to reciprocate this one, then I don't have to do the rationalizing. All right, here we're going to need to rationalize, and here it's just 3/2 for cosecant. Remember, these guys are related, sine and cosecant, cosine and secant are also related. So 3/5, 3 over root 5, rationalize, and we get 3 root 5 over 5. All right, so those would be our answers. Hopefully that was clear. All right, here is another one for you. So now we're just saying, okay, notice my angle, my theta is the central angle nearest the center of the near the origin. We went 2 units and down 4. So this is 2, this is down 4. We can find our radius, and voila, you've got it. So I won't do that one for you. I'll let you do that if you haven't done it already. All right, last thing. So here I have a blank unit circle, and it's really helpful. I think on the quiz I'm gonna give you a blank unit circle so you can fill it in. You don't have to fill the whole thing in. You can just fill in the ones that you need for these values. Okay, so sine of 120. Let's read the directions, because directions are so important. Determine the exact value for each of the following trig functions. Okay, sine of 120. All right, where is 120? Let's see. 90, it's 30 more than 90. So I kind of like to go off of the ones that I'm comfortable with. So this is 90, 180. All right, so 30 more would be right here. Right, so this is my angle that I'm talking about. Now I'm going to use my reference angle, really, to figure out the value, because this reference angle is similar to this angle, right? And I know this is 1/2 root 3 over 2, right? Short side, long side of a 30, 60, 90. So 1/2 root 3 over 2, same thing here. 1/2, if I do a triangle, negative 1/2, right? Negative 1/2, and up root 3 over 2. So if I were you, I would fill in the cosines and sine, the coordinate, for that angle. So now I'm asked for the sine of 120. So sine of 120 is root 3 over 2. All right, now I'm asked for cosine of 210. Let's see. From 180, I need 20, 30 more. So we're 30 past 180. So here's 180, here's 210. 210 degrees. Okay, so what's my reference angle? It looks like 30 degrees. So same as this 30 degrees, root 3 over 2 is the long side, 1/2 is the short side, but here I'm going back and down. So back and down. Back root 3 over 2, and down 1/2. So that would be my ordered pair, and I'm asked to find cosine, so I'm asked to find the first coordinate. The x value would be cosine, negative root 3 over 2. All right? Tangent. Let's do one more. Tangent of a negative 30 degrees. So I'm going to go down 30 right here. If I go down 30 degrees, again, same coordinates, but now I'm going positive, negative. So I go positive root 3 over 2, negative 1/2, and I'm asked to find tangent. All right, now tangent is cosine over sine. All right, so cosine over sine, I'm going to go root 3 over 2 over a negative 1/2. Now the 2's kind of simplify out. I can just say, all right, times 2 over 2. All right, and the 2's simplify, so I just get root 3 over 1, or negative. So my answer for this one would be negative root 3. Okay, there was a little bit of work needed. I may have done, it would have been better maybe to do that over on the side and then put my final answer there. But hopefully that helps. For this guy, you need to count it out. Figure out where is 765. All right, good luck on your quiz. Hopefully this video helps. All right, thanks for watching.